All right, this is Algebra 1, Lesson 2. We're learning about angles, polygons, triangles, and quadrilaterals. A big geometry review again. So here we're talking about lines that intersect, which just means that they cross, and lines that never intersect are parallel. Doesn't matter how long you draw the lines out, they are never going to cross. Super simple, right? Intersecting lines, parallel lines. Okay, now we're talking about where they intersect. There are angles formed. So here was an angle formed right there, this little space in between. Here an angle was formed, that little space in between. All of that. So they're talking about perpendicular lines, which means a right angle is formed. That's that little right angle signal. They're talking about two right angles, if they're side by side, create a straight angle. And if you remember, a straight angle is 180 degrees. So from this line going around to here is 180 degrees. So here we have four right angles. 1, 2, 3, 4 formed there. Here are two right angles squished up beside each other. That makes a straight angle. And here, if they do not create right angles, we have two acute angles, which means they are less than 90 degrees, two obtuse angles, which means they are greater than 90 degrees. Okay, so here again, intersecting lines versus parallel lines. We've got different kinds of angles, right angles, straight angles, acute and obtuse angles. Okay. Here they're just showing a little bit more about that there are 90 degrees in a right angle. Here they're showing again 180 degrees in a straight line. And here they're showing if you want to make a circle, that is like 4 right angles combined, which is 360 degrees. Again, lots of geometry review. All right, now we go on to polygons. Polygons just are shapes that are formed by straight lines. These are not polygons. And this is not a polygon because these lines intersect and cross here. Now, if you would have said, okay, this right here, that is a polygon. Yes, it is. But over here, yes, this is a polygon. But when you put them together, that's not a polygon. Same here. This has an opening and this has a curved line. It is not a straight line. So those are all not polygons. So then on the next page, they're showing examples of figures that are polygons. Triangle, quadrilateral, pentagon, hexagon, heptagon, octagon, and it tells you all of the different things. 3 sides, 3 vertices. So the vertices are the points right here, right here, right here. And of course the sides are side, side, side. So we've got 3, 4, 5, 6, 7, 8. And then it tells you down here, okay, so what if you have more than 7 or 8 sides? Okay, so 9 sides is a nonagon, 10 sides is a decagon, 11 is an undecagon, and 12 is a dodecagon. Okay. Here's a handy little chart that talks again, that makes it even more simple. Tells you how many sides and the name of the polygon. Okay, down here at the bottom, it's talking about concave and convex polygons. Concave means that one of the sides comes in a little bit. And then this goes out everywhere. Okay, so none of the lines come in close. They all stay out to the outside. So concave, it's like you're creating a little cave or space on the inside. Convex is no spaces like that are in the inside. Okay, moving on to page 6 in your book. We are talking about different kinds of polygons, and we have the word equilateral here. Lateral is sides. So this means that the sides are the same length. These little dash marks here, that means that each side is the same. So if this was 5, that would be 5, 5, 5, 5, 5, all the way around. Okay, here, if you have these lines, these like semicircle things here, and then the line through them, that delineates and says that these angles that are marked like this, the same exact way, are equiangular, which means that they measure the same degree. So those are the same angle measures. Here is what's called a regular polygon, which means every side is the same, every angle is the same. Okay, so if only the sides are the same, it's equilateral. If only the angles are the same, it's equiangular. And if both the sides and the angles are the same, it's a regular polygon. Okay, so here we go. We've got a regular triangle, a regular quadrilateral, regular pentagon, and a regular hexagon. So all of these, this is going to have all 3 sides are the same, all 3 angles are the same, all 4 sides are the same, all 4 angles are the same, etc., etc. Okay? Okay, so now we're talking about specifically triangles and the kinds of triangles that you can have. So triangles can be named based on their angle measures or based on their sides. So for example here, this is called a right triangle because it has 1 right angle. This is called an acute triangle because it has 3 acute angles. This is called an obtuse triangle because one of the angles is obtuse. And this is called an equiangular triangle because all of the angles are the same. So these triangles are all named based on the angles in the triangle. Okay, so now these triangles are given names based on their sides. So this is called an isosceles triangle because 2 of the sides are the same. Do you see how this has 1 hash mark, this has 1 hash mark, so that means that these 2 sides are the same. So that's an isosceles triangle. An equilateral triangle means all 3 sides are the same. A scalene triangle means none of them are the same. So this has a 1 hash mark, this has 2, this has 3. That means none of those sides are the same. So these triangles have names based on their sides. Isosceles, equilateral, scalene. All right, so you're going to be given some problems where you have to find missing parts in triangles. Okay, so if you remember, if you add up all of the angles in a triangle, you get 180 degrees. So this number, 130 plus 30 is 160. So x has to be 20 in order for us to get 180 degrees. So that's what they worked through right here. Okay. Down here we have a triangle, and it's a special triangle. It is an isosceles triangle. It has 2 sides that are the same. And when you have 2 sides that are the same, these 2 angles are actually the same. So if this is 50 degrees, this should be 50 degrees. Okay? So now we know 50 and 50, that's 100 degrees. All of it together is 180. So we have to take 180 minus 100, and we should get 80 degrees right there for y. So that's what they worked through right here. 50 plus 50 plus 80 is 180. Okay? So you should be able to do this down here as well. This is just a little bit trickier because this is an isosceles triangle. If you see this is 8, this is 8, that means that these 2 should be the exact same length or measure of angle. Not a length, angle measure, okay? So 180 degrees minus 110 degrees is 70 degrees. So this angle plus this angle should equal 70 degrees, and both of them are the same. So you should be able to take 70 degrees divided by 2 and get 35 degrees for y and 35 degrees for x. The answer should be on the next page. So there it is. Therefore, x equals 35 and y equals 35. So they're going to walk you all the way through how to do that. Okay? And last but not least, we have special kinds of quadrilaterals. Parallelogram. Two sets of sides are parallel. These two are parallel. These two are parallel. Okay? Trapezoid means the top and the bottom or the sides are parallel. Doesn't matter which one, as long as only one of the sets are parallel. Okay? A rectangle is a parallelogram with 4 right angles, which means these two lines have to be parallel, these two lines have to be parallel, and every angle is 90 degrees. Okay? A rhombus is an equilateral parallelogram. So these two lines have to be parallel, these two lines have to be parallel, and every single side is the same measurement. And then, of course, the square is a rhombus. It's the same thing as a rhombus. It just has 4 right angles.